Okay, today I'm going to go over with you the set of real numbers and their subsets. So the set of real numbers includes two main subsets. One's called rational numbers and one's called irrational numbers. So this is what the set of real numbers Venn diagram looks like, and you should have a copy of this page. And as we fill in examples, I'll come back to this Venn diagram. So the set of rational numbers has actually three subsets: integers, whole numbers, and natural numbers. And we're going to start with natural numbers and go over that definition. So natural numbers are sometimes called just your counting numbers. They're the numbers that you learned to count with as a child. For example, 1, 2, 3, 4, and so forth. So they're positive numbers and they start with the number 1. So if we want to go back to this Venn diagram, if I was going to put natural numbers here, I'd put 1, 2, 3, 4, and then maybe dot, 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 and so forth. So the number 5,000 would be a natural number. Okay, the next subset of rational numbers is your whole numbers. Your whole numbers are the set of your counting numbers, so it's all your natural or counting numbers, but it also includes 0. So instead of starting with 1, we're going to start with 0. So that's the only difference. So it's 0, 1, 2, 3, 4, 5, and up. So positive numbers with 0. I always put it like a 0, or the whole number has an O in it, which looks like a 0. So you know whole numbers starts with the number 0. So if we go back to our Venn diagram, I'm going to put 0, 1, 2, 3, and then dot, 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 and so forth. Okay, so the next set that we're going to look at, or subset, is your integers. Your integers are any whole number and its negative. So it's basically positive and negative whole numbers, including 0. So if you think of a number line, it's your positive plus your negative numbers that are all whole numbers. So no fractions or decimals yet, but it includes the negative side of a number line. So when we go to the Venn diagram, integers, I'm going to just say like -4, -3, -2, -1, 0, and then also your positive numbers. 1, 2, 3. Okay, so it could be like -18, -70. But if it's negative, it's going to be an integer, but it can't be a fraction or decimal yet. So the next subset is your rational numbers. Now these are numbers that can be written as a ratio, or that means it just can be written as a fraction. So if it's a decimal, it has to end or repeat, and those are considered rational numbers also. So a fraction like 3/5 would be a rational number. It could be a mixed number like 4 2/3. It could be a decimal like 0.3. And it could be a repeating decimal, like if it has 0.55 and a bar over it, that means I know that repeats. And that would also be a rational number. So on our Venn diagram here for rational numbers, I'm going to put I'll do like 5 2/3, that would be rational. 4/5 is rational. It could be a decimal like 6.825. That's a decimal that ends, so that's rational. Or it could be a repeating decimal like 0.33 repeating. 0.33 repeating can be expressed as a fraction, which is 1/3. That's how we know it's rational. So if the decimal ends, like 6.825, it stops. Or if it has that bar over it and lets us know it repeats, then those are going to be rational examples also. Okay, now let's look at irrational numbers. We're going to go to this slide. Okay, an irrational number is a number that cannot be written as a ratio of two numbers. They are decimals that never end or never repeat. So an example of an irrational number, the square root of 8 would be irrational. If you put that in the calculator, it's going to be a decimal that keeps going all the way to the end of your calculator screen. It doesn't end. Another example, 4.53224636, and then you see the dot, dot, dot. That means that decimal keeps on going forever. It never ends, so that's going to be irrational. Square root of 30 would also be irrational. If you put that in your calculator, it's going to keep going forever. And then pi is probably the most famous irrational number. So when we go back to our Venn diagram, I'm going to put pi in here. I'm going to put like 3.62157, and then I'm going to put dot, dot, dot. That means that decimal doesn't end. It keeps going forever. If I try to do the square root of, let's say, 6, that cannot be expressed as a fraction. That's going to be a decimal that keeps going to the end of your calculator screen, which means it keeps going on forever and ever. Another one would be like square root of 12. Any number that's not a perfect square is going to be irrational. Okay? And those are your sets and subsets of real numbers. One thing I do want to point out is all your natural numbers are also whole numbers, and all your whole numbers are integers, and all your integers are rational numbers. So these all are in the set of rational numbers, but rational and irrational numbers don't overlap or intersect. Okay, so hopefully this video will help you on your assignment today. Let me know if you have any questions. Thanks.